Hello, everyone. My name is Ryan Worth, and I'm part of the Fall 2020 Metis Data Science Bootcamp. A little bit about myself. 3 years ago, I graduated with a degree in physics before eventually entering the web development world. Over the last few years, I've been able to really hone my programming skills. I'm now looking to combine my mathematical and analytical background from physics with my programming skills, which naturally leads me into the data science, data analytics world. This project is just one step along the way of that eventual transition process. So today I'll be discussing with you my system for automating basketball highlights using object tracking. So my motivation behind this, I wanted to find an inexpensive basic alternative for cutting up game film and extracting important game information. What do I mean by inexpensive and basic? I mean that all you need is the actual basketball broadcast. You don't need fancy cameras set up. You don't need fancy tracking devices set up, just the basketball broadcast. So what are some example use cases? Well, the first I see is for TV networks to be able to quickly create game highlights and recaps. This is already how a large portion of the fan base consumes the games. So being able to quickly and efficiently upload them, create them and upload them is of the utmost importance for these networks. Next would be for basketball teams. Teams spend numerous man hours every season simply cutting up game footage for later analyzation. If we can automate this monotonous process, we'd be able to transfer those man hours to the actually important process of analyzing these clips. And lastly, a little bit outside the box, something like fantasy sports. Having player-specific highlight reels would be a benefit to any fantasy sports application. However, it's virtually impossible to do this without automating it en masse. The first question we need to answer in this problem is how do you identify basketball? And this may seem relatively simple, but in the course of a basketball broadcast, the basketball will not always appear uniform. Here you can see it looks a little bit blurry and oval shaped. While a player dribbles it, it appears as if it's connected to the player, like there or here. Sometimes the player may be obstructing your view of the ball, or the ball may be on top of a dark background, so on and so forth, till you quickly realize it is not a trivial task. We can't use our normal computer vision techniques to answer this question. Luckily for us, we have neural networks. I trained a model on roughly 1,000 images of basketballs and made baskets, so it could identify both in any given frame. It goes without saying, this was not perfect. Here you can see a misidentification where it believed this woman's hair was a made basket. It is in fact not. So it's important to understand that our neural network is not the end-all be-all, and rather just a framework that we then have to interpret. So adding on some logic. One thing I did was set a very high confidence threshold. What I realized is that on actual true made baskets, my model was very confident. So by setting a high threshold, I was able to weed out a lot of the false positives. In addition to that, setting rules like needing to see 3 consecutive made basket frames before we actually count a basket, weeded out a lot of the 1 or 2 frame inconsistencies I saw throughout the footage. And lastly, setting a cooldown after a made basket was identified prevented me from double counting any basket if there was a lot of commotion around the rim. So far, after we could identify the basketball, we wanted to start identifying the players. What I did is I utilized a pre-trained neural network. And as you can see here, I added to my pipeline, and it is indeed able to identify the players on the court. But which team are they on? To answer that, I used OpenCV and computer vision to grab each player's bounding box and take a ratio of its light pixels versus its dark pixels. The lower the ratio, the more likely the player was to be on the lighter team. The higher the ratio, the more likely the player was to be on the darker team. And here you can see the result of this. It was able to correctly label each individual team. However, if a player on the light jersey was on top of a dark background, it was prone to mislabeling. So in order to account for this, I implemented player tracking. Up until now, we've been using object detection, where each frame is processed independently of the one before it or the one after it. Tracking, however, creates an object from these detections and connects it frame to frame over the whole video. This looks something like this. We're able to track this person as he dribbles the ball up the court and keep a specific ID on him, person number 1. What this allows us to do is create a running average of the pixel ratio within their bounding box to better separate out which team each player is on. And here is my final result. After feeding in a 3-minute long footage that my model had never seen before, this is the output. It attempts to identify made baskets, it attempts to identify the player possession, and this is the highlight reel. So it starts with the dark team with the ball, and it correctly identifies the made basket, and that was the highlight reel. Now it cuts out a lot of dead time and gets to our next made basket. Again, it was able to correctly identify the possession. Here, it correctly identifies the made basket, but misidentifies the possession. And here you can see a misidentification of a made basket. There's a lot of commotion happening behind the net, and it thought there was a made basket when there was not. And our last one, again, correctly identifies the made basket. So there you can see what my model outputted, the highlight reel that it was able to produce from that 3-minute clip. So in summary, what I would like to do next is more training, more training, more training. On top of that, being able to utilize jersey numbers to better help with player tracking. And lastly, being able to identify 3-pointers, 2-pointers, free throws, and other key plays throughout a game. And from there, it's a slam dunk. Thank you very much for watching. I hope you enjoyed.